This is Force Quiz 1 review. Fill in the blank. The force that supports an object is called the normal force. So that would be letter B. The normal force. The force that resists the motion of an object is the force of friction. So that's letter A. Okay, if an object is, let's draw a quick picture over here. An object is sliding down a hill or a ramp, we'll say. The force of friction, F sub F, is what resists that. So this has a velocity that's headed down the hill or toward the right. The friction is going to resist that motion. I should probably say that the direction of motion would be right down the hill. Friction resists that. C, the force that keeps an object hanging from a string, a rope, a chain, something like that, is the force tension. That's letter E. The force that holds you to the earth, pulls you toward the center of the earth, it's the force of gravity. And the force that causes a stretched rubber band or a balloon that's compressed to deform and then return to its original shape is called the elastic force. Okay, vocabulary. A force created by gravity that's acting on a mass. This is called the weight force, or weight. Okay. Gravity acting on you or I on a mass. This force is called weight. A push or pull, any action that has the ability to change motion, is simply called a force. These forces do not involve physical contact. Do not involve physical contact between the agent and the receiver, but they act through space. This is called a field force. That's letter F. Okay, number 9. This is a force where the agent and the receiver are touching. Right, so if you have touching, this is called a contact force. That is letter G. Number 10. The amount of matter or stuff that an object contains. This is called mass. 10 is B. 11. The blank applies the force. That's the agent applies the force. It's letter D. The receiver accepts the force, feels the force, receives the force. It's letter E. 13. The total, that's the key word, of all forces acting on an object. This is called the net force, H. Okay, 14 and 15, true-false statements. Friction force acts in the same direction as the motion of a moving object. We drew this picture up here at the beginning. We said friction resists motion, so the object's moving down the hill. Okay, friction is resisting it by pointing up the hill. So friction acts in the same direction. That's false. So false, and you would have clicked in letter B for that. The normal force acts perpendicular to the supporting surface. And that is true. So you've clicked in A for that. And I'll draw that on that same scenario. So if you have a box that's sliding down a ramp, there's my box sliding down the ramp. We know that the force of gravity always points straight down toward the center of the earth, but the force normal, or the support force, is going to point perpendicular, or 90 degrees to the surface. If the box was resting on a flat table, gravity would still point straight down toward the center of the earth. In this case, force normal would point straight up, but notice force normal is still perpendicular, or at 90 degrees to the surface. Okay? These images we're going to analyze here on the back. Looking at a table at rest on a floor. If the agent is the earth, Earth applies the force of gravity. The receiver is the table. And the effect is that it just stays at rest or it stays down on the ground. The next picture, we have a tire hanging from a rope or a tire swing. So if the agent is the rope, ropes apply a force called force tension. The tire is receiving that. And you could have said a number of things like it is deformed. Okay, that tire will be slightly deformed, or you could say that the tire is supported. In other words, it's held up off the ground. Something like that's acceptable. Okay, in this case, we're going to draw force diagrams. Question 18. First, circle your system. It's a skier and his skis. Okay, he's in mid-air. We're ignoring air resistance. The only force on this guy is the force of gravity. There's nothing supporting him. Number 19, we're drawing the force diagram for the sled and the packages that are attached to a rope. So we have the force of gravity always pointing straight down. In this case, the surface is parallel to the sled. So force normal is straight up. In other words, it is 90 degrees to the surface. You have a tension force on the sled, and then you have a very small force friction since we're on snow. Okay, pull all of those off of the picture and put them on a force diagram. Force gravity down. Force normal up. Force tension at that angle of the rope. And then your small force friction. It's the force diagram. And in the last two questions, we're calculating net force. We remember from an earlier question, net means total. So what's the total force acting on this object? If the two forces, or however many forces there are pointing in the same direction, you simply add them. So we just have 8 plus 10. We have 18 newtons, and you could say to the east, 18 newtons to the right. Either is acceptable. Again, two arrows pointing in the same direction, you add them. In this case, you have, looks like this photocopy didn't turn out well. This arrow's pointing left. All right, these arrows are acting in different directions on the basketball. So we're going to subtract. 20 minus 15 is a net force of 5 newtons, and the net force is going to be in the direction of west or left, and this because the larger force is pointing left. So we could say maybe that force wins, or the object will accelerate that way since the greater force is pointing that way.